Hello, in December of 2012, I posted a video of my son and I replacing the outside temperature display on my 1994 Mercedes E320 sedan. As you probably remember, the display sometimes would come on, but most of the time it would be blank or be flashing partial digits. So I purchased a used one from eBay for 20 bucks and replaced it. I kept the old display, and today I decided to take it apart and see if I could find anything wrong. So let me show you the results and how to take this display apart. Okay, so to take this display apart, it's pretty straightforward. There are 4 Phillips screws. There's 1, 2, and then there's 2 more in the back, 1 and 2 here. And I already loosened these guys, so you basically just have to pull these guys out. And then this plastic case just splits right in half, like so. Okay, and then you can see that it's a fairly straightforward design here. It has these 5 pins or lugs that simply snap in to these plastic holders right here. Then there's this little board right here which is held in place by 2 screws, which we're going to take off pretty soon. And then the LCD display is in this plastic holder. So this plastic holder comes off just like this. And then you can remove the 5 pins. Now, don't worry about the position then, because as you can see, they're self-aligning. So there's no way that you can cross them. They kind of line up with the plastic pieces right here. So now let me take this little PCB out of this LCD holder. And there are 2 Phillips screws right here, so let me do that next. Okay, so I've removed the 2 Phillips screws right here, and this little PCB just comes straight out, and you'll be able to see that right here in front there's an LED, and this is the illumination LED. So when you turn your headlights or parking lights on, this LED comes on. And you can adjust the brightness via the rheostat that's on in the dash. So you will notice also that the LCD display itself is located inside this plastic housing, and the fact that it's not blacked out and before it was coming on partially means that the LCD display itself is okay. So the problem must be on this PCB board. And if you look at this PCB board, there's besides the LED, there's a whole bunch of resistors and capacitors and perhaps some diodes and transistors. They're all surface mount technology. So if you don't get a big voltage spike in here or some electrostatic discharge, you will not, these devices here cannot be easily damaged. But you will notice, however, that there are 2 capacitors here. And in particular, this large one here is an electrolytic. And over time, electrolytic capacitors can break down in either of 2 ways. Either they dry themselves out or they leak out. Now in this particular case, I noticed that the earlier or the older capacitor, the original capacitor, which happens to be right here, was actually leaking. I could see some wet spots on the PCB. Therefore, when I took an ohm meter to it, it was basically open circuited. So what I did is I replaced it, and as you can probably see right here, let me bring out the new one. The new one is actually larger than the original one. Diameter-wise it's the same, but the length one is larger, but that's okay. The old one is a 47 microfarad, 16 volts. I chose to put a larger one. This is 100 microfarad, 25 volts. So the moral of the story is, as long as you put a capacitor that's equal to or larger than the original one, you're going to be fine. Now this happens to be longer, but there's plenty of room inside the plastic casing to handle that. So that's not a problem at all. So earlier when I did this, I put it back together and I tested it, and the LCD works just fine. So once again, I'm going to reassemble it, and then I'll show you how to test the LCD module. Okay, so just one more note I forgot to mention here. These capacitors are polarized. That means that there's a plus sign and minus sign. And the capacitors are pretty straightforward. You can see, well, probably not, but there's a stripe, a gray stripe with a minus sign on it. And on the board, the minus sign goes towards the outside of the little PCB there. So just be careful with the polarity of the capacitor. Okay, so I've reassembled the module, and as you can see, it's actually displaying plus 29 degrees Fahrenheit, and I'll get to that in a moment. But you can see the black lead, that's going to pin 1, which is the ground pin. The red lead of the power supply is outputting 12 volts, and it's going to pin 5 of the module. Pin 3 is where the sensor input goes into. Now don't forget, the sensor is behind the license plate, the front license plate. And it goes through the firewall and it comes into this module on pin number 3. The second lead of the sensor goes to ground, which is pin number 1. Pin 2 on this module is the backlight for the display, and we can test it out later. But basically, with the 10K across pins 3 and 1, okay, according to the instructions, we should be reading 0 degrees Celsius. 0 degrees Celsius, of course, is 32 degrees Fahrenheit. But that was with 9,800 ohms. I have 10,000 ohms, so we're reading 29 degrees F, which is pretty darn close. Okay, so that's about it. And as I said, if you move the red lead to pin number 2, then you can see that the LED backlight comes on as well. I'm not going to do it now, but that's about it. So this was a nice, easy, inexpensive fix.